This video is on the effect of solvents on rates of reaction. Solvents are extremely important in organic reactions. You have to choose the right solvent, or otherwise reaction might not even work. A solvent has a couple basic requirements. First, it must dissolve reagents so they can come in contact with one another. And secondly, the solvent itself cannot react with the reagents. Otherwise, you will not get the reaction you want. Recall that like dissolves like. So to select your solvent, you're probably going to need polar solvents, mostly because the functional groups you'll be dealing with tend to be polar. Non-polar functional groups being your typical alkane. But back to polar solvents. Polar solvents stabilize ions and polar molecules. SN1 proceeds via a carbocation. Therefore, polar solvents will stabilize said carbocation, and therefore SN1 reactions will proceed much faster in polar solvents. For SN2 reactions, the nucleophile can be charged or neutral. If the nucleophile is charged, the polar solvents can stabilize it, therefore decreasing the rate of reaction. However, if the nucleophile is neutral, the polar solvent will stabilize the transition state, but not affect the nucleophile, increasing the rate of reaction. Solvents can also be categorized as protic or aprotic. Protic means that it has a proton bonded to oxygen or nitrogen, allowing for hydrogen bonding. Hydrogen bonding really hinders charged nucleophiles, disfavoring SN2. Aprotic is the absence of protons, so there is no hydrogen bonding available. This favors SN2. So if we look at polar protic solvents, these favor SN1 reactions and can favor SN2 reactions under certain conditions, whilst polar aprotic solvents favor SN2 reactions.